Western Blotting, Part 2, Polyacrylamide Gel Electrophoresis. The goal of polyacrylamide gel electrophoresis, or PAGE, is to separate proteins within a protein lysate according to size, shape, and/or charge. To accomplish this, protein lysates are loaded onto a gel matrix. The matrix is made up of holes through which proteins can pass. The smaller the protein, the faster it will pass through the holes in the gel matrix. The bigger the protein, the longer it will take to go through the gel matrix. To form a gel matrix, a catalyst and polymerizing agent are added to a liquid solution containing two different acrylamide compounds, acrylamide and bisacrylamide. The catalyst and polymerizing agent accelerate the formation of long, single-chain polymers of acrylamide in the solution. Gel formation requires the presence of bisacrylamide, which cross-links two polyacrylamide molecules together, forming a microscopic matrix or mesh through which proteins can pass. The size of the spaces created in the gel matrix is inversely correlated with the amount of acrylamide used in the starting gel solution. A lower percentage of acrylamide in the starting gel solution results in larger spaces in the polyacrylamide matrix and greater separation of large proteins. For resolving smaller proteins, a higher percentage of polyacrylamide in the starting gel solution is used, resulting in smaller spacing in the matrix and better separation of low molecular weight proteins. In PAGE, the gel solution containing the acrylamide compounds, catalyst, and polymerizing agent is prepared and quickly poured between two plates anchored vertically in a cassette. A small plastic comb is placed at the top to create wells where the protein lysates can be loaded. As the liquid solution hardens, a flexible, thin gel forms between the glass plates. Once the gel completely polymerizes, the gel cassette is inserted into a chamber, which contains buffer to allow the conduction of current through the gel, with a negative electrode positioned at the top of the gel chamber and the positive electrode positioned at the bottom of the chamber. Several forms of polyacrylamide gel electrophoresis, or PAGE, exist. The two most commonly used are 1. Non-denaturing or native PAGE, and 2. Denaturing or SDS PAGE. In non-denaturing or native PAGE, proteins retain their native folded state and separate in the gel matrix according to their native net charge, mass, and shape. A protein's overall electric charge is determined by the charge of its individual amino acids and the charge of any additional chemical modification. The more negatively charged the protein is, the faster the protein will migrate through the gel matrix towards the positive electrode. Since proteins retain their native folded state when running a native PAGE, their mass as well as their shape will also impact their migration through the gel matrix. Small, compact proteins will migrate faster through the gel matrix, while large or elongated proteins will migrate more slowly. Therefore, native PAGE can be used to assess the addition of a charged chemical modification, the binding of additional molecules or proteins, and a protein's quaternary structure. In a denaturing gel, proteins are assessed in a denatured or unfolded state and separated in the gel matrix according to their mass only. To accomplish this, sodium dodecyl sulfate, or SDS, an anionic detergent, is added to denature proteins and uniformly coat them with a negative charge. This means that proteins with similar mass but different shapes migrate at similar rates in an SDS PAGE. By the same token, proteins with similar mass but different overall charges also migrate through the gel matrix at comparable rates. This property of SDS PAGE makes it particularly suitable for assessing changes that affect the mass of a protein, such as covalent modifications or changes in protein expression. During SDS PAGE, SDS is added to the gel solution, protein samples, and running buffer to ensure that proteins remain negatively charged and unfolded throughout the procedure. For the rest of this animation, we will use SDS PAGE to illustrate subsequent steps in the Western blotting procedure. Before running a polyacrylamide gel, researchers need a way to easily load the protein samples into the wells, which are immersed in running buffer, and monitor the proteins as they migrate through the gel since proteins are mostly colorless. To do this, a dye solution called sample buffer is added to the protein lysates. Sample buffer contains an additive such as glycerol, which makes the sample buffer denser than the surrounding running buffer, causing the samples to sink to the bottom of the wells rather than mixing with the surrounding buffer. Sample buffer also contains a negatively charged dye, typically bromophenol blue, used to monitor the progress of electrophoresis. Tracking or loading dyes, as they are often referred to, have low molecular weights and migrate ahead of most proteins within the protein sample. Once the protein lysate and sample buffer mixture are ready, the protein samples are heated in sample buffer for a short time to facilitate protein unfolding for SDS page. In addition, sample buffer contains beta-mercaptoethanol and DTT to disrupt disulfide bonds, further assisting in protein unfolding by disrupting quaternary structure. To assess the molecular weight of a protein after gel electrophoresis, a sample, called a protein ladder, containing several pre-stained proteins of known size is loaded and run along with the experimental samples. The use of protein ladders with pre-stained proteins increases visibility and facilitates monitoring of protein migration through the gel. After loading the protein lysates and ladder, the gel is run by connecting the chamber to a power supply. Once protein samples have been run and separated through gel electrophoresis, the gel may be stained to visualize the separated proteins directly or processed further for Western blotting. Gel staining is typically done to visualize all of the proteins present. This is especially helpful if we need to isolate and purify proteins with a particular molecular weight. Some commonly used methods for staining polyacrylamide gels are Kumasi blue, silver staining, and negative staining using zinc compounds.